In addition to being able to handle exceptions as we've done up until now, our code can actually throw exceptions as well. And that would just be in any case where we want to signal that an error has occurred. So we might throw an exception because our code has identified something wrong with the data we're working on. Or it might even be that our code has caught an exception and wants to throw a different exception to provide more information. Now, the way we throw an exception is quite easy. We simply use the throw keyword and then provide an instance of the exception we want to throw. Now remember that exceptions are objects, so they have to be created before they can be thrown. So we just create them with the new keyword. And one of the most important things to remember when throwing an exception is that you want to be sure that you provide meaningful detail. We want to make it easy for whoever has to handle this exception to be able to figure out what was wrong. Now most exception classes provide a constructor that accepts a string message or some other detail. So you want to make sure you put as much meaningful information into that as you can. Now, as we said, sometimes we'll throw an exception because our code caught an exception and we want to add some more information to it. Well, in that situation, you want to always make sure that your new exception that you throw includes the original exception. You don't want to lose that detail. And this idea of tying one exception to another is very fundamental to the exception classes. All the exception classes have a method called init calls that will allow you to associate an exception with an instance of another exception. But this idea of associating exceptions together is so fundamental that many exception classes actually provide a constructor that will accept the other exception, so you can actually create the new exception and associate the original all in one step. Now, in most cases, when you're throwing an exception, you're going to want to throw one of the existing exception types. But it is possible to create your own custom exception types and throw those as well. Now, to really reinforce this, in most cases, you're going to want to use one of the existing exception types. But if you really have a situation where you've got something you need to provide information on that doesn't really fit one of the existing exceptions, you can define your own. But again, that's going to be one of these situations where you've got some real information, some real value to provide that you can't with the existing exception types. Now, if you do define your own custom exception type, you're generally going to inherit from the exception class. But that has an interesting implication. Remember that any exception that inherits from the exception class but not the runtime exception class is a checked exception. So the exceptions you define will become checked exceptions. The process of implementing a custom exception type is generally pretty easy. In fact, very often, the only members that your exception type will have will be constructors. And the reason for that is that most of the required functionality is inherited. The base classes have the ability for you to associate a string message and have the receiver of the exception access that message. The base classes provide things like stack traces. So you generally don't need to provide a lot more than that. I mean, there may be some situations where there's some extended error detail you might want to add. In those cases, you might have some additional getter methods to access those, but there's not going to be a lot of that. Now, when you define your custom exception type, you'll generally want to have at least two constructors. You'll have one constructor that accepts whatever the required detail is. That may be a simple string message. It may be some meaningful fields. You'll generally also want to have another constructor that accepts that same detail along with an originating exception. Again, so that if this exception is thrown in response to a different exception, they can be tied together. And you can, of course, have more constructors than that if you want to. You can have a no argument constructor. You can have whatever you need. But you'll generally have at least these two. Now, in the next clip, we'll take a look at how we can actually define a custom exception in code and how we actually throw it. In this demo, we'll add exceptions to our Calc Engine app. We'll create a custom exception class, which we'll then throw in cases where we find we have invalid data. And then, of course, we'll add a try-catch block to our app to handle those exceptions. Here we are in the source code for our Calc Engine app. And the app is exactly as we left it at the end of the last module, except I've added 3 more statements for us to process. Remember that each statement that we process is supposed to have 3 parts, a command, and then the 2 numbers we want to operate on. Well, each of these 3 statements I've added have a different problem. The first statement contains only 2 parts, the command and a single numeric value instead of having 2 values. The second statement has non-numeric data, the XX. And then the third statement I added has an invalid command, add X. So what we want to do is update the app so that we can properly handle this invalid data. So the first thing we'll do is add our own custom exception class. So I'm going to go ahead and create a class just like I always do, because remember, exception classes are just classes. And let's call this the invalid statement exception. We'll say OK. Now remember that all of our exception classes will generally extend the class exception. So let's go ahead and do that. And as I mentioned in the previous clip, in most cases, any custom exceptions really only have constructors inside of them. Right? So let's go ahead and add a public constructor for this. And this constructor will take two arguments: the reason that a statement is invalid and the statement itself. So they'll both be string parameters. And then all we need to do here is go ahead and call our superclass constructor. So I'll say super. And one of these superclass constructors accepts a string, which is a message. So what we'll do is we'll take these two parts, the reason and the statement, and combine them into a single message. So that's our first constructor. Now remember we said that normally there are two constructors. One that accepts the information that we need, which we have here, and also one that lets us associate another exception with it. So what I'm going to do here is going to grab this first constructor, just copy that. I'll paste it in. And what I'm going to do on this second constructor here is add in a throwable cause. So we've got the cause there, and all we're going to do is pass that to our base class constructor. And we now have a custom exception. Because remember that all the real work of being an exception we're inheriting from the base class. Right? So we're really ready now to have our own custom exception. So now what we need to do is add in the appropriate error checks into our code. Right? So let's go to our calculate helper class here. And here we are inside the process method. Remember, the job of the process method is to take that string statement, break it into its parts, and then do the right work under the covers. So remember that we said there are three things we're going to start checking for. Now, the first one was to make sure that we have enough parts to the incoming statement. So the right place to check for that is right here after we call split. Because when we call split, we get back an array with all the parts. Right? So what we want to do is make sure that array has exactly 3 members in it. So let's put an if statement in place. We'll just check to see if the parts length is equal to 3. Or I should say if the parts length is not equal to 3. And then if it's not equal to 3, what we're going to do is throw an instance of our exception. So we're going to say throw. We're going to new up an instance of our exception. Remember, our exception is the invalid statement exception. Remember that we want to pass this one 2 parameters: the reason that something is wrong, and then the statement itself. So the reason we'll say is incorrect number of fields. And then we'll pass our statement in. And so now we're throwing an exception there. So that takes care of the not having enough parts to it. Now the next issue was that of non-numeric data. Now the way we're going to find out we have non-numeric data is that when we call these parse double methods, they'll actually throw a number format exception if that data is not numeric. So we'll do in this case here where we actually convert the strings into doubles. Let's wrap that in a try catch block to handle number format exception. So we've got that there. So let's go ahead and complete our catch block. And again, we'll throw our invalid statement exception. This time our reason will be non-numeric data. So we've got our reason and the statement. But this time we want to add a third parameter, which is the original exception. Because we don't want to lose the fact that this was actually triggered by another exception. So we've got that there. So that takes care of our non-numeric data situation. Now the last thing we need to check for is an invalid command. Remember, the command is set by this set command from string method. If I scroll down and look at that, remember that set command from string actually takes that string value, goes through and tries to compare it with each one of the enumerations, and when it finds it, it sets the appropriate enumeration to our command field. So if we leave set command from string and the command field is still null, we know it's an invalid command. So what we'll do is we'll scroll up here. Right after we get back from set command from string, we'll check and see if that command field is null. And if it is, we'll again throw our invalid statement exception, with the reason being invalid command. So now we have all of our error checking inside of our process method, and we raise all these exceptions. But you notice that each one of these throws is underlined in red by my IDE. Well, the reason is it's complaining that I haven't handled this exception. Now, of course, I could put a try catch block in here to handle these exceptions, but obviously I don't want to do that because I want the caller to get the exception. So what I need to do then is go up here to my method declaration and add a throws clause for invalid statement exception. Because remember, our custom exceptions are checked exceptions. Right? So now we've indicated that we throw that exception. So now if we go back to our main program, you'll notice that where we call process is now underlined in red because we're not handling the exception. Right? The method declares that it throws it, so we have to handle it. So we'll wrap this in a try catch block. And what I'm going to do is put the try catch block inside the for statement because I want to make sure that if I get an error on one statement, I still process the next statement. If I put the entire for loop inside the try block, as soon as there was any error, it would jump out of the try block into the catch, and I wouldn't process anything else. So let's put a try block right in here. So we'll wrap the body of our for in the try. Then we'll catch the invalid statement exception. So we've got that there, and of course, we'll put our catch block in place. Let me just scroll a little bit so we can see a little better. And what I want to do, of course, is print out the error message. And the way I get to the error message is I just go to the exception, and I call its getMessage method. And that'll write out the message for that exception. And that message for our exception was set when we called the base class constructor. Now remember that in some cases, we'll have not only our exception, but another exception. What we want to do is look inside of this exception and see if there's another exception that was the calls inside of there. So I'm going to put an if statement here again. I'm going to say e.getCalls. And that checks to see if there's a calls associated with this, which is the other exception. Okay, well, if the calls comes back as non-null, that means that we know that there was a calls. So if the calls comes back as non-null, that means that there's another exception here. So what I'm going to do in this case is write out the message from that exception. So I call e.getCalls to get the original exception, and then call getMessage on that one. And so now when I go through here, anytime we get an invalid statement exception, we'll write out the message for that invalid statement exception. And if there was another exception inside of it, we'll write out that message as well. So let's go ahead and run this guy and let's see what it looks like now. All right, so we ran to completion. Let me make this window a little larger so we can see everything. And you notice here, everything worked like we expected. Right, the first statement was had an invalid number of fields because it only had 2 fields inside of it, the add and 1.0, so we see that there. The next one had non-numeric data, right, the XX. So notice we write out our message, non-numeric data, and show the statement. But even we show the original exception, which pinpoints the fact that it was the XX. So that XX came from the number format exception that was raised. And then our last erroneous one had that addX, which was an invalid command, which it wrote out appropriately. And then for the next 4, which are actually correct, those processed just fine. So we've now used a custom exception to signal our error, provide the caller with adequate information that they could then handle in their try-catch block. To wrap up, remember our focus in this module is on exceptions. And exceptions provide us a non-intrusive way to signal errors. And when we're working with exceptions, we use try, catch, and finally to provide a structured way to handle those exceptions. The try block is the work we want to perform normally. The catch block is what we want to do if something goes wrong. And finally gives us a common place to put our cleanup code. Now remember that exceptions are typed and can be caught by type. So you can have a separate catch statement for differing exception types. You can provide very specific handling for each type. Remember though, you want to catch from most specific type to least specific because the system checks from the top down on the catches, and the first catch it encounters that it can assign that exception type to it will use. So if you've got a more specific handler, you want to put that before your more general handler. Remember the exceptions are raised using the throw keyword, but remember that if a method has any checked exceptions that it doesn't catch, then it must declare that those exceptions can occur by using the throws clause on the method declaration. Now normally when we throw exceptions, we want to choose one of the built-in exceptions, but if we need to, we can create our own custom exception types. And normally those exception types will inherit from the exception class, which makes our custom exceptions checked exceptions.